previous sections, we actually talked about scattering parameters, the scattering matrix, the S matrix. And I mentioned a few advantages of this matrix. However, it is not the only useful one. We're going to see essentially very quickly, very shortly, two transmission matrices, the ABCD matrix and the T matrix, that are essentially very useful tools in analyzing networks. So why transmission matrix is quite useful? The first and most interesting, I would say, part of this discussion is that a lot of the networks that we use are simply two-port networks. And there are specific matrices like the ABCD that treat two-port networks very nicely. The second reason is that most of our systems are essentially nothing else than a cascade of individual two-port modules. And when we do that, it's quite interesting. If you know the parameters of each one of these modules, then it would be nice if you can basically calculate very quickly the parameters of the entire chain. And it turns out that with the ABCD matrix, for example, all you have to do to calculate the parameters of the entire chain is just multiply the ABCD parameters of each individual module. And so that makes calculating the entire matrix an amazingly simple process compared to the scattering matrix. So that's the reason why people are using additional parameters and they're not only stuck with the scattering matrix. So first of all, the ABCD matrix is something that you may have seen before. It's essentially a matrix that relates the voltage and the current at the input with the voltage and the current at the output. So you can see the voltage and current definition at the input port. You can see the voltage and current definition at the output port. But one thing I do want you to especially pay attention to is the direction of I2. I2 normally in almost every other matrix is actually defined consistently with I1 as actually flowing into the port. In our case, I2 for the ABCD matrix is actually defined as flowing out of the port. And that's the only thing you have to pay attention compared, for example, to any Z or Y matrix that you may see out there. Other than that, the calculation of the ABCD matrix flows in a very similar way to any other matrix, as shown in these equations. And there are specific attributes that you can find out, which we're not going to actually prove in this class. Now, as I mentioned before, the big advantage of the ABCD matrix is that if you do cascade two networks and you do know the ABCD of each one of those networks, then the ABCD of the entire network, as shown here, can be proven to be nothing else than just the multiplication of each matrix. And so it's a very useful technique when you analyze systems. Now, if you open any book or if you just look online, you will find out that the ABCD parameters of some very useful networks are already available for you. So you don't even have to calculate them. For example, a series impedance has a very simple ABCD matrix shown right here. And you can also find very quickly very convenient ways to translate one matrix to another. For example, if you do know the S parameters of a network, it's very simple to find the ABCD parameters of the same network. And of course, the same thing is true the other way as well. So really, it's all about just matrix manipulation to go from one to the next.